start off with another brand new chapter. Right. So before that, I want to do a quick recap with all of you on what you have learned previously. Right. It's always good for us to do a revision because of the forgetting curve. Still remember, most of you maybe only can retain about 30 to 40% after 7 days. Okay. So it's important to raise your retention rate. Alright, so what I will do is okay, I'll show you this one. Okay. I managed to do the debugging, troubleshooting. So this week it works. Sorry, I haven't project my screen. How come? It's already on. Oh, it's freeze. Okay, so this is the web application, very simple website to randomly select one of you to answer some of my questions. We are now doing a revision, everyone, revision only. Okay, so I used to use Kahoot last time to do revision with students, but unfortunately Kahoot starting from previous semester can only support up to 20 students for a single sections. Okay, for more than 20 students I need to pay. So I don't want to use Kahoot. Okay, because I want everyone to participate. If I use Kahoot, only 20 of you can actually join in to the sections. Right. So just ask you some questions verbally. Okay. I'm not sure whether it's a good timing for me to start because looking at your attendance now at the moment, most likely a lot of you will not be in this class at the moment. Alright. Let me ask you a question before I pick someone to answer me. Okay. See whether you are lucky today. Okay, so last chapter we basically talk about what? Okay, and also the lecture before last lecture, right? Okay, I used 2 sections to talk about technologies underlying blockchain technology. Those technology that are essentials for you to support blockchain, right? Without them, it's very hard for you to realize these new technologies. Okay, we talk about hash function. We talk about public key cryptography. We also touch a little bit about peer-to-peer network, and also we study a very important things in blockchain technology, which is called consensus protocol, right, or consensus mechanism, right? And then I introduced to you 2 very important consensus protocols. Okay, so one is called the proof of work, another one is called proof of stake. These 2, right? Okay. What else? Wow, I also cannot remember. See, the forgetting curve. What I remember getting less and less. I think same happened to you. Alright, so let's do a quick recap before we move to our new chapter. Right? Okay, my first question. Actually, this is doing a revision. Okay. Very simple. I'll start with a very simple one. Okay. Yes or no question. At least you have 50-50 chance. Okay, you learn about hash function. May I know, hash function, is it used for you to encrypt your transaction? Okay, don't worry, I pick someone. Hopefully you work. Hopefully you work. Okay, I need to choose from your name list first. This is created by ChatGPT. Name list here. Okay, so I already put all of you inside this web page, Alright, so let me pick someone. So see who is the lucky one? Hello. Wow. Which one is your surname? Chong, okay. Terror, is it pronounced as Terror or Terror? Oh. Terror, are you here? Oh yeah, Terror. Hi, nice to meet you. Now I recognize your face. Okay, Terror. You're so lucky, you made the history, you know. You're the first guy pick up at the system. Not me, don't blame me. Okay, Terror. Is hash functions used to encrypt transactions? Really?
No.
Is a hash function, you know, okay, like MD5, SHA-256, or another one, specially designed for this Ethereum one, CAPTCHA-256, okay, there are many hash function up there, okay, so this hash function used for you to encrypt transactions? Our friend, Terror? Yes, okay, the answer is no, no. Hash function is not used for that purpose. Okay? So what's the purpose of using a hash function?
Fixed size.
Basically, to allow you to have a fingerprint, to create a fingerprint, okay? That can be used to represent your original input, right? Can be a very large file, okay? And if there is any change to your original input, the output of the hash function, is called hash value, will definitely will not be the same, okay? If the original input, okay, after some modifications, alteration, okay, become a thing, even though it's a very small change, if you run through the same hash function, okay, output will definitely change a lot, okay? Even though the hash value is fixed size, but the content is totally different. We can notice. Okay, so the use of hash function is not for you to encrypt anything. Okay, once you have turned an input into an output, right? There's no way for you to get back to the original input. Right? Remember, it's irreversible. Okay, it's one-way function. Right? If you are saying that hash function can be used for encryption, we need to say after that, well, I have the encrypted message, for example, I will have a way to get back to my my original plain text, right? You're expecting to get back to the original plain text, right? Not the ciphertext, right? Okay. So hash functions is not for that purpose. But if you are using an encryption algorithm, yes, like those RSA and so on, yes, you can do the encryption. Okay, if you are using public key cryptography like RSA, okay, you can encrypt either using your public key or private key. I will have a way to decode, to decrypt, okay, back to the original plain text using the corresponding key, right? Okay. All right. Okay. Thank you, Tara. Okay. I'm not sure whether the program come up by ChatGPT will have repetition or not. Whether Terror will be selected again, I'm not sure. I don't know how it works. I think it should be random. Okay. But even though it's random, maybe you have a chance to be selected again. Okay, my last question. Next question. All right. Okay, talking about public key. Easiest one. How many keys are there in public key cryptography? The guy selected very lucky. Okay, very easy question. Okay, Junbing, where are you? Okay, Junbing. Okay, how many keys are there when I talk about public key cryptography? 2, not 3, 2, Okay, so one is called? Which one you should keep it to yourself? Yeah, very good, Alright, so this will lead to the next question. Okay. There is one important thing used in blockchain is digital signature. I think you heard about this signature. Tell me how you get your digital signature. If you have a digital signature with you, that means, for example, your message or your transaction is signed. Okay? After you sign the thing you want to sign, you get digital signature. Correct? Then you attach the digital signature together with your original message or transaction. Okay? This is this signature. But how this digital signature is created? Okay, this is my question. Okay. Oh, Brandon, are you here?
照片全部
Are you here? Please raise your hand.
照
No?
片全部是男
Can someone pretend to be Brandon, please? Brandon not here? Okay. Get another one.
春好
Okay. Junho. Who is Junho? Oh, very good. Okay. So, how we get our digital signature? How we, in another word, how we sign our transaction, for example. Okay, transaction is something that you want to sign. Okay, how you sign your transaction, that means how you get your digital signature. After you sign, you get your digital signature, right? So how? What is the process? There are two steps. And it's related to your private key, mentioned by our friend just now, right? Got two key, right? Public key and private key, right? When we sign, we don't use public key, nothing to do with public key, okay? But it's to do with your private key. So how? No idea? Okay. Let me see, get someone to help, okay? Help Chun Ho, is it? Okay, Xiao Xian. Right, Xiao Xian? Oh, very good. It's not far away from me. Okay, so how you actually sign, let's say your transaction, we always use transaction as example because in blockchain got a lot of transaction that we need to sign, right? Okay, so how you sign your transaction so that at the end you get your digital signature to be attached together with your transaction. That's the process. Remember to use your private key. Not really sure. Okay? The process is like this, very simple, very easy to remember. First, you hash your transaction, no matter what is it, messages or whatever. You hash the thing you want to sign. Okay? Hash it. Let's say transaction. What is the transaction? It depends on application, right? For voting application, maybe inside there got the candidate you want to work for, how many work, okay, and so on, right? Okay, transaction always depend on your application, right? That's what we discussed. Okay, so this is a transaction you must sign. So you first hash it, hash the transaction, and then what you get? Hash value, right? Okay, and you cannot stop there. Cannot yet. This user is not created yet. So the hash value that you get is a fixed length, right? It's very small as compared to the original input, right? Okay. So this hash value, you need to use your private key to encrypt. So you hash the thing, and the hash value you encrypt. So at the end, in short, we call it encrypted hash value, okay? So the encrypted hash value that I'm talking about is your digital signature. Okay? Okay? It's important because you want to make sure that the transaction is actually really initiated by the right person. So you say this is my transaction. I will be able to verify through your digital signature. Why? Why I can verify? Hey, you send me the transaction, you give me the attachment, digital signature together with your transaction, then you expect me to be able to confirm this one have not been changed. First thing is sending from you, it is initiated by you. You crafted this transaction. Why? Because you also will provide the public key information. Because public key for you is nothing. It's not any secret you can share with anyone, right? Okay, so you include your public key information, you just pass it to me, then I will use a public key because this is your public key, okay, which is not a secret. Then I go and decrypt your encrypted hash value, right? Okay, so what you get, hash value lah, okay? But when I be able to decrypt using a public key successfully means it must be encrypted using your private key. And in the whole world, only you have that private key, right? Then I confirm already. You are the one who actually signed the transaction, right? Without any doubt. Second thing, with the hash value, I can compare. Is there any changes made to the transaction that you sent originally and the one I received, right? If I compare the hash value, because after decrypting, I got the hash value, then I can compare with the one I calculate myself. I calculate, right, the transaction hash value with the one you provided after I can get it. I compare the two. If exactly the same, that means no changes. So that's why digital signature is so important in this blockchain for you to be able to verify the sender, okay, and ensure the authenticity lah, okay. Okay, next we move to another topic. We talk about hash function, public key cryptography. Now I want to move to consensus protocol. Okay, the basic question first. Okay, the question is why we need a consensus protocol in blockchain. Why we need a consensus protocol? Okay, ask yourself whether you really know. It's a very important question for you to understand. Okay, singing. Where is singing? Hi. Oh, you're singing. Oh, okay. Singing, tell me. Why we need consensus protocol? Why you are here must study consensus protocol? There's no way that I can remove from your syllabus. Why? It's very important. Everyone must think also, even though you are not picked by the system. Any idea? Yeah, basically correct. Okay, you want to make sure the state of the blockchain. Okay, I use this very simple term, the state of blockchain. Okay, that means the transactions inside your ledger okay, must be consistent. Okay, so your block number is the same as my block number, then the transactions must be exactly the same. I have a 2010 transaction inside my block, you also might have 2010 transaction in my block, and then the order also the same. Transaction A, transaction B, transaction C, and your side also the same. Everything must be the same. Okay, but it's not easy to achieve. Okay, that's why we need to find out a way to make this happen, because there's so many nodes in our network, right? To make this happen is very susah. Fortunately, we have a lot of ideas. Okay, so the way to make this happen is called consensus protocol or consensus mechanism. Right. So I learned about two major ones, right? Although there are a bunch of consensus protocol that we have, but we only study two, focus on two. One is called proof of work. All right. Next question. What it is meant by the work in this proof of work? Okay, what does it mean? Okay, by this work, W-O-R-K. What kind of work actually all the miners are doing? Okay, who is Chen Yong? Are you here, Chen Yong? Okay. Hi, Chen Yong. How are you? Hungry now? Okay. So, what's the work that we are talking about? All the nodes are doing what kind of thing? Actually, the ultimate goal is to come up with a block, right? Okay, a single block that recognized, accepted by everyone, right? To be added to the ledger, right? So, in this processor protocol, everyone who want to propose a new block, they do this. So, what kind of thing they are doing? Yeah, solve a mathematical puzzle, right? Okay, find out the right nonce so that at the end the hash value will give you some leading zero in front, right? And the difficulty depends on how many zero you want. The more zero, more difficult. Okay, yes, correct. Okay, so this kind of consensus protocol, is it power efficient or energy saving? Okay, everyone answer me. This is too easy. Is it? No, it's very, very power consumptive. Use up a lot of your electric power. Right? Okay, so that's why we switch to another alternative. Okay. Originally, Ethereum also the same, proof of work. Then later on to last year, okay, they moved to this proof of stake already. Okay, so in proof of stake, instead of having miners to do the job, miners all doing the same thing, right? All the miners whoever want to earn reward, so they do this work, right? Okay, to solve the middle puzzle, right? Okay, so my question is, in proof of stake, we do call it miner. So who are the ones that going to propose the new block? Okay. Henry? Hi, Henry? No? Where are you, Henry? Okay, Henry. So we do have miner, okay, in proof of stake. So we have what? We still need someone to propose a new block, right? So the guy who's going to propose a new block is called? So you see, revision is very important, no? Who is going to propose a new block now? It's called? Start with V.
Vicky.
Yes, validators, right? Okay. So as compared to proof of work, every miners can do, compete, okay, and use up a lot of electricity, okay. But in proof of stake, we have a selected pool of validator. Not only one person, there is a selected pool of validator that going to propose a new block. Okay, so in proof of stake, we have time slot. We have slot 1. Okay, so for one slot, of course, we come up with one block. Okay, but this block will be proposed by one of the validators who are lucky. Okay, inside that pool, we have a pool of validator for that time slot, one slot. Okay, one slot got maybe 20, 30, I don't know. Okay, and then one lucky guy will be selected from there to propose. Hey, this is a block we use. We put all the transactions inside the block and then tell all the validator in that time slot. Okay, I propose. Then all of you, what you need to do? You need to vote. Vote. Okay, okay or not? The one I propose. Okay, if no problem, that will be the one that with the block that everyone in the network need to add to their ledger. Okay? Of course, who will be selected to become validator? It depends on the money that you stake. Okay? Cryptocurrency that you stake. Okay? The more you stake, the higher the chance you will get. Okay? Of course, some of the validator might not be following the rules. Might behave dishonestly. Some may go offline, lazy, shut down the node. Okay, and so on. So in case this kind of thing happen, okay, so there is a mechanism there to prevent. So we don't want to see this kind of thing happen. You are lucky, you are selected as a validator. You must do your job properly. Okay, and always online. Okay, how can I actually prevent you from behave dishonestly, okay, or voting wrongly and so on, okay, or go offline. So how can I prevent this from happening? Okay. Hey, is it called again?
Yeah.
Yeah, repeated. Who is Xiao Xian? Cannot remember. Oh, okay. You're so lucky, system like you, Okay, Chen Zhen. Okay, who is Chen Zhen? Okay, Chen Zhen. So to prevent those dishonor validator, those lazy validators, or we sometimes go offline and so on. So we will. So what, according to the protocol, what will happen if you have this kind of validator? Common sense. Let's say you are always late for my class, what I will do? Okay, there will be penalties. Penalties. Okay, how to penalize those validators behave dishonestly, sometimes go offline and so on? What we can do? We will take a certain portion of their money stake. They have take money, right, to become a validator, right? If they are not doing the job, then we say, oh, they are not doing the job, they will take maybe 20% or 50%. It's something called slashing, to slash their deposit. Remember, this is the best way to deal with those validators. Oh, that's what we can do. Nothing we can do, right? They have money on our this hand, right? Okay. So we can have protocol to agree. If you are not behaving honestly, lazy and so on, then we'll slash your money. We'll reduce. You lose. Basically, you lose a portion of your money deposited. Remember, you need to deposit a certain amount of money. Money here refer to the cryptocurrency to take part in the this block proposing, right? Okay, I think we have finished discussing about the consensus protocol. Now we go to the last part before we continue with our lecture today. Last question. Okay, so in blockchain world, we don't have a centralized authority entity and so on to actually give you identity, right? Okay, no one will give you a username and password for you to actually use the blockchain, right? Okay, so to overcome this, we will need to have a mechanism to come up with address, okay, and also a way for people to know you are the rightful participant and so on. Okay, so we use public key cryptography for this purpose, right? Okay, so they are very clever. They actually create a pair of this key, okay, to serve as the address of a certain blockchain network, like Bitcoin or Ethereum. Address, they create the address, right? Address actually is your account, okay, for that particular network, okay. So for you to get the address, so what is the first thing to do? What we need to do to get address? Okay, my Bitcoin address, my Ethereum address, I want it. I cannot ask from you. I cannot ask from her. I need to create on my own. Okay, so what is the first step that we take to come up with, okay, at the end, a proper address for me to use, and it will be belonging to me, okay, and people will believe that address is belonging to me without any doubt. Okay, oh, kanjiong time. Okay, Ziyao, where are you? Oh, okay. You're blocking me. Okay, Ziyao. So what is the first step, the very first step in address generation? Create a wallet. Okay lah. Okay, actually a wallet will help you to create, right? Okay lah. Your first step is to create a wallet. Okay. So what will wallet do? As their first step to create address for you. Same thing. Okay, you say wallet, okay lah, I accept. And then this wallet, of course, will do it for you, do the job for you to create the address for you, right? So what's the first step the wallet will do? Anything, sir? Okay, I give you answer directly. Okay, the first step is always the same. no matter Bitcoin or Ethereum, to get address first, generate a random private key.
Private key.
Generate a random private key. First step. Okay? And after that, you will go through some hashing encoding and so on, right? Until you get your
Bitcoin.
this address. Because after you have the private key, you can get your corresponding public key. So you do some manipulation to your public key, make it look nicer with the length that we want and other characteristics. Then it become a proper address that you can use that going to represent your ownership. This address generated belonging to whose is actually very easy to verify because it's only corresponding to one single private key that you get initially as your first step, right? It's corresponding to that private key. As long as you have the private key, then you can actually sign for the transactions initiated by that account or that address. Okay? So you can see the usage of public key cryptography in this case. Okay, clear? That's why it's very important for you to keep your private key properly. Okay, if you lose the knowledge about this corresponding private key that is generated for your address, or the money that go into your address, you won't be able to spend because this blockchain network also like Bitcoin, Ethereum also will require you to sign. Want to use? Okay. Wow, a lot of Ether inside Bitcoin inside. Yeah, you feel free to spend. But when you want to spend, you need to sign the transaction. Okay, and then it will require your knowledge on your private key. Okay, so no one can spend for you. You are the owner because you know the private key. Remember, no key, no coin. Okay? No key, no coin. Okay, with that we stop this for a while. Okay, don't worry, don't not pick later on. I'll still ask you. Okay, so we spend how much time? Wow, a lot of time for this. Okay, so I've read this lecture today into 2 sections. I don't think I can cover all of them. Alright, let's go through slowly. I forgot to switch off. Alright, so today onward, we are going to explore more on blockchain platform. This is called blockchain platform. Okay, you know roughly how blockchain work, right? Okay, so we need a platform actually to support this blockchain technologies. There are a lot, but we choose this one. This is a very famous one. Okay, very famous one, especially for this application that required to use smart contract. This is the platform that we can use. Alright. Okay, so this is the creator of Ethereum. Okay, Vitalik Buterin. Okay, so he is actually a Russian. Originated from Russia. Okay, but I think he moved to Canada when he was young. Okay, together with his father. Alright, his father. His father is also a IT guy okay, working in IT area. Okay, so this fellow very skinny one okay, actually very interested in Bitcoin. Okay, since the inception of Bitcoin, since the start of Bitcoin, he follow the development of Bitcoin. He also involved in writing magazine related to Bitcoin. You know, okay, so he knows Bitcoins very well. Okay, how it works and so on. Okay, the white paper the yellow paper, white paper. I think he's very familiar with. Okay, but you find out okay, there are some limitations of the Bitcoin network because of Bitcoin. You know, it only can allow you to do fund transfer. Other than that, you cannot do, right? Bitcoin can do anything else. Cannot, right? Yeah, can only allow you to transfer funds. Alright. Okay, so that's why he has this idea, okay, to come up with another platform, okay, that allows general purpose, to allow various kinds of use, okay, to to support various applications, not only for fund transfer. Supposed to be able to solve whatever problem we want. Okay? So, we come up with this Ethereum. Right? And together with another guy, his partner, Dr. Gavin Wu, is also a very famous one. Remember, I think he was at the age of 17 or what when he created, is it 17 or 21st? Okay, he created this Ethereum at a very young age, okay, younger than you. He already created this Ethereum blockchain platform. Okay, right. So basically, Ethereum is after Bitcoin. Okay, Bitcoin created in years 2009, right? Okay, 2009. And this Ethereum actually created when? Oh, okay. The ideas first come out in 2013. About 4 years, 4 years after the emergence of this Bitcoin. 4 years after that. Okay. All right. So what are the improvements made by Vitalik? Okay. Because the idea is to come up with a Turing complete blockchain. Turing complete. Okay, have you heard about Turing complete problem before? If you're studying computer science, you know, right? Okay, right. So the idea is very simple. Okay, as long as you give me enough time, you give me enough resources, you give me the right instruction, I suppose be able to solve the problem you want. Okay, agree or not? Give me enough resources, the memory the machine okay, and so on, right? Okay, and give me enough time of course. I don't expect me to solve your problem in 0.1 millisecond and so on, okay? Some of your problems can be very complicated, but as long as you give it enough time, enough resources, and also you must give me correct instruction. With this three things, to solve your problem, it's not a problem. Okay, I can solve for you. Okay, this is like a general computer that we have today, okay, can solve many different problems as long as you provide the correct applications and so on, right? Okay. All right. So to achieve this, you need to have a drastic change in the design of Bitcoin. Bitcoin cannot. Okay. So what kind of things added by Vitalik? Okay. So basically, these are the three major things, okay, considered as new innovations, okay, at that time. Okay, first we have EVM, EVM. Okay, this is a virtual machine, just like your JVM, Java Virtual Machine. Do you know Java? Yes, right. So once you have written your Java program, right, it can be run in different platforms. As long as you got this JVM installed, right? Correct? Okay? Java Virtual Machine. So the idea is still the same. Okay? So I want to run program. Not like Bitcoin, I just concerned about transferring fund. Okay? I don't consider other. So if I want my platform be able to execute any kind of program, I need this kind of virtual machine, okay, to understand my code and run it for me, execute for me. Correct or not? Okay, so EVM is a new introduction to blockchain. Okay, before that we don't have EVM, right? Okay, and then also smart contract. Okay, so he also added the idea of smart contract so that you can execute code. Okay, smart contract basically is your code. Okay, and this code of course is not stored in your server or whatever. Okay, the special idea is that this Vitalik want to store the program, the smart contract, inside blockchain. Okay, inside blockchain. Because whatever that you have put inside, whatever smart contract that is deployed, it cannot be changed anymore after deployment. It's very secure. It's a secure platform, okay, for it to store. Okay, no one can change. And also it's a platform that can guarantee the execution of your program without any bias or whatever. When it should be executed, it will be executed. Okay. Okay. So you just need to turn whatever things that you want to do, your procedure or everything, okay, into smart contract, and I get it run in using this Ethereum platform. Okay. Okay, and then also there are some other things actually. I only introduced 3 important innovation later Ethereum to all of you okay. And third one is actually improve blockchain design. Okay. For example, Merkle tree. Okay. I believe you all know already why we want to have a data structure called Merkle tree, right? Okay. But because of the blockchain platform this Vitalik Buterin want to build is very different from this Bitcoin, because you need to support execution of program. Okay. Then the Merkle tree structure will no longer relevant. Okay, to host those information. Okay, later information in this Ethereum's blockchain platform. Okay, so okay, it changed the design. Okay, and it's a big change actually. Okay, we are going to go through together also the new variants of Merkle tree. Okay, later on next week. Okay, so they have a few. Why he made this kind of changes? Okay, of course that part I think from my past experience it's quite hard for you to comprehend fully. Very hard for you to understand. Okay, of course don't worry that part I will make it as good to know. Okay, for this course. You know, for any course we have something called things that you must know, something good to know, and something you don't need to know. Don't need to know, of course you will see here. But you will see some good to know content. Okay, very difficult. Okay, I did ask one time in the final, most students cannot answer. Okay, so that one make it as good to know. Okay, so with it is okay, then it's possible for Ethereum, okay, to actually solve a lot of problem for you, so it become a Turing complete blockchain platform or Turing complete machine okay. You can treat actually Ethereum as a global computer, no problem for that, right? Computer meant for is used for you to solve your problem. You can do programming, right? Okay, computer. Okay. So here also the same. You can write code, smart contract. Okay, it can be run. Okay. However, the difference is it's no longer okay residing in a centralized server and so on. Actually, the code will be executed on every node on the network. Remember, in a blockchain network, we always have a lot of nodes, right? Okay, all of the nodes will execute the same code. Okay, so it becomes something like you can imagine it's like a global computer. Okay, we don't know where exactly is the computer, right? But don't say this is a supercomputer. You don't treat Ethereum as a supercomputer. No, it's not going to have that kind of high performance. Okay, you cannot expect that to happen. Actually, very slow. Okay, but you can consider as a global computer to actually complete a Turing complete okay task. Can you give me an example of you see Ethereum can be considered Turing complete machine because it can solve various kinds of problem for you, right? Okay, can do a lot of tasks for you, different tasks. Can you give me one example of machine that you know is not Turing complete? That means it can do a single thing. Other than that, it cannot do. Very easy, Okay. Give me one example of a machine which is not Turing complete. Okay, Meng Wen. Are you here, Meng Wen? Hey. Not here? Who is Meng Wen? Not here. Okay, choose another one. Okay, Nicholas. Okay, Nicholas. Okay, hi, Nicholas. Give me one simple example of a machine that can only do one thing. Okay. Any? Vending machine, Okay, yes, vending machine, Can you ask vending machines to do other things for you? Cannot, right? Okay. Another very simple example is the calculator that you use. Okay. during your high school time, okay, you need to take your calculator together with you for your exam, right? That calculator can only do what? Calculation. Other than that, you cannot do. Okay, you cannot browse internet, you cannot listen to a song using your calculator, right? Okay, a general computer, yes, can do a lot of things, but a calculator is a very typical example of non-Turing complete machine. Okay, but Ethereum is a Turing complete. You can do whatever you want as long as you give the three things: resources, times, and correct instruction, right? Okay. Okay. Let's continue. Okay, now let's explore some of the important concepts. Okay, we slowly talk about important concept in the Ethereum. I know you have come to the part of writing smart contract. I believe in your practical, right? Have you used this Remix to write? Yes. Okay, you know what's the Ethereum, okay? But I do believe you are not very clear about some important concept in Ethereum. Okay, you just follow the instruction. Okay, you say first this step, and then you send the coin to someone, blah, 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 and so on, right? You just follow the step inside a practical. But actually there are a lot of things inside Ethereum, the concept that you need to know. We start with the very first one. Okay, first we talk about Ethereum node. Okay, so basically Ethereum, like other blockchain network, also got a lot of distributed node. Okay, they are all connected. Of course, every node don't need to connect to all the nodes in the network. It's not possible one. Okay, so Ethereum node just need to connect to some of the node nearby. Okay, but they are all connected. They are all connected. Okay, there are three types of node actually. Okay, so the first one is called full node. Okay, full node is the node that's going to store the full blockchain data. Okay. So all the state can be derived from a full node. Whatever information, for example, the value of a variable inside a smart contract and so on, you can get from this full node directly, no problem. Okay, if you hold all this information, all the information will be available in full node. Okay. Okay, and then they need to run the proof of work and so on. Okay, if they are trying to become the validator okay, in other words, if you want only okay, then you will need to run those consensus mechanism. Okay, this, if you are talking about layers, then this one will be related to consensus layer. Okay, so inside a node, everyone can actually become an Ethereum node. You also can just go and download to the website and download. Okay, so there inside the software that you downloaded, actually there are many layers. Okay, so you will get this consensus layer client inside your node. You have this execution layer clients also. Just a piece of software. We refer to them as those clients, execution clients. Okay, for example, the how to actually do some validation, verifications and so on. Okay, how to actually add the block to the ledger and so on. All those general protocol actually handled by this execution layer. Okay, handled by execution layer. And then for the consensus layer part, it's handled by this part of your software. Okay, the download software, actually there are many parts handling different kind of things. That is not important. I don't want to emphasize. Okay. Then we have light nodes also. Light node. Light node is a node that actually is not so powerful. Okay, maybe you are running as a Ethereum node using Raspberry Pi, let's say, okay, or using your handphone and so on. Okay, of course it's not going to be as powerful as your this server, as your other this desktop and so on, right? Okay, so in this case you cannot expect them to actually to store a lot of things, to store the whole ledger. You cannot expect this kind of node to do a lot of work for you okay, so they can be a light node. Okay, if you have a light node, you still can actually participate in this transaction validation, so no problem. Whenever you want to get information for validation, okay, verification and so on, okay, you can actually request from your peer, from not peer anymore, okay, from those full node. You must request from full node. You cannot request from light node, useless. Light nodes also they are the same. They're not having enough information for you, so you need to look for full node they are connected to. Ask for information, help you to do whatever things you want to do. Okay, so this is light node. And of course, it's not going to be the validator. Okay, not possible. Of course, there is another kind of node called archive. Basically, this is not so important for you to know. Basically, used for those explorer and so on. Okay, whoever want to have a statistical analysis, okay, to know what happens inside the Ethereum network and so on. For example, Explorer, Ethereum Explorer, Etherscan and so on. Okay, they can maintain archive node. They hold everything for the very beginning, the first block until the current block. Okay, all the information is actually available to this archive node. Okay, so let's take a look at the structure or the components of a Ethereum node. Okay, look something like this. Okay, just give you an idea. All right. Okay, this is how they are connected. The whole thing is called Ethereum network. This is a network. Okay, there are many nodes there. Okay, of course it's not that small. You can imagine there are a lot of, I don't know how many nodes are there at the moment. Okay, you can Google. Right, so some will be running as a full node, and some will be the validator. Okay, so they are not interested in getting money, so they just become a full node. Okay, and some are interested to become validators. Okay, and then they are connected, but they are not connected to all. Okay, you cannot expect a full connection like this one connect to this one. Okay, and so on. They just connect to some of the neighbors only. Okay. Okay, if I enlarge a full node, you look like this. Okay, so we have all these components. Okay. All right, so this is Ethereum clients. Okay, so this is a runtime. Okay, for your this transaction. Okay. The first component, okay, is called JSON RPC API. Okay. Basically, this is to expose Ethereum function, okay, to the user, to your application, to the DF that you want to develop. Okay, you can actually request these Ethereum clients to do the job for you. For example, you want to send Ether, right? Okay, then you use the right API for that purpose, okay. If you want to know about, let's say, the balance of accounts and so on, okay, they also can use the right API to access. Okay, and this API is based on this protocol called JSON RPC. Okay, of course, don't worry. Even though the complications with these components is at this low level. Okay, as a developer like you, you just need to use the correct library. Okay, to interact. Okay, you don't need to take care about the low communications, low level communications with this component. Or else you need to really understand the protocol. Okay, it's very hard for you. Okay, usually we just use web3.js if you are using JavaScript. Okay, we use this kind of library to actually make our life easier. Okay, it will handle those low level JSON RPC communication for you. It's very easy. Okay. Okay, so basically all the available APIs is exposed to the user or applications via this component. Okay, then we have something called client process. Basically, this is just to do the coordination. Okay, to make sure that the transaction coming in will go to the right place. Okay, where to go, where the transaction should go next, and so on. Right. Okay, so when a transaction coming here, this client process will first actually put it inside this memory pool. Okay, this memory pool. I should put it here first. Okay, when you receive a transaction, let's say a transaction come here, it will be stored here because your node is going to receive a lot of transaction. Okay, maybe in 1 second got maybe 100 or even thousands of transactions, who knows, right? Okay, so you won't be able to handle so fast. You need to keep it somewhere first. So it's temporary. You store inside this memory pool. Okay, this memory pool. Okay, then you need to have EVMs also. Okay, because in Ethereum you need to execute the transaction. Okay, sometimes your transaction is a function invocation. Okay, you invoke certain functions in your smart contract. Okay, if this kind of transactions, okay, you need to actually pass it to EVM. For execution. You need to execute and get the result. Okay, get the result. Okay. All right. So after that, the transactions, will be this put inside the block by validator. And then the validator will actually append. After validation, it will append to the ledger. So this is basically the process, the components, the major roles of all these components inside this Ethereum node. Okay, after talking about node, now we go to another concept. Today we just talk about some important concept, in Ethereum. The next one we're talking about account. This one we have mentioned already previously. So you know how we get the address. How we get the address inside this maybe Bitcoin or inside Ethereum. So in Ethereum it's a bit different from Bitcoin. You can see there are two types of account. In Bitcoin you have only just one type of account, which is a user account. That's all. Only one type of account. But in Ethereum there are two. Because you have smart contract. The first one is called externally owned account, EOA. So what is that? Very simple. It's actually just a normal user account. It just we just give it a very this chunky name, a very fancy name. But actually it's just a normal user account. Nothing different from your Bitcoin user account. And then we have a contract account. Contract account is the account given to the contract that you have deployed. That you have deployed. And of course, there is a way for the protocol, to assign an account, to this contract that you assign. And it's not controlled by you. You cannot control. The user account, yes, you can create on your own, right? You ask your wallet and so on to create this account for you, right? Your wallet will actually pick up a random this private key. We discussed the first step is to create a private key, right? And then come up with a corresponding public key, do some manipulation and get your this account or address, right? This is called EOA. Just a trick. This one as your normal user account. And of course, you have the control over this account. As long as you have the corresponding private key, then you own this account, EOA. Remember, this is how you own. But this one is not. This one is not. This one is controlled by the code, the program inside the smart contract. This contract account will only be assigned after you have finished the deployment of your smart contract. After you deploy to the network, only it will be assigned. It follows certain parameter to create the address. And this account can hold money. Can hold Ether. So this is a comparison between the two. You can see here, contract account also can hold Ether, can have Ether balance, and then your normal user account also the same. Okay, then you can see from here, only your normal user account or EOA can actually start transaction. Okay, transaction cannot be initiated from your smart contract. Okay, transaction can only be initiated by user account. Okay, and then this is talking about the internal call message lah. Okay, if you want to call a function from another contract, yes, it's possible. Okay, but it's not possible using your EOA. Okay, maybe later on I will talk more about this transaction. What does it mean by this? Start transaction message. This is very important for you to know. Okay, I usually will explain more when I come to the smart contract part. When we talk about this view function, pure functions, and so on. At that time, I will relate to this transaction. Okay, so in Ethereum, when you want to send a transaction, actually you'll be charged. You need to pay the transaction fee one. It's not like your conventional application, right? You don't care, like just call the function of API as many times as you like lah. Okay, if you are calling a function by sending a transaction, you will be charged. Okay, because the transactions that you send out will be broadcasted. Okay, you broadcasted. Okay, you broadcasted first to the node that you are connecting with. Okay, your application must connect to one of the node of the network. Must connect to one of the node of the network. Must connect. Because the transaction initiated by the application must go somewhere, right? Before it can reach up to the rest of the network, right? Okay, you must make sure your applications is connected to one of the node. Okay, and from there you get propagated lah. Okay, and then it will be processed lah. Okay, it will process mean some verification job, validation job will be done by those nodes lah. Okay, receiving this transaction from you. So every node in the network will receive a copy of your transaction when we send out a transaction from our applications. You see, this will cause all the nodes need to work for you because they need to process your transaction. And because of this, do you think that you will be given free of charge for sending this transaction? Okay, remember, no, whenever you kacau orang lain, okay, correct not? Okay, you send to all a transaction. A transaction will be broadcasted. Okay, so for sure, all the nodes will need to do some work, and because of this, you will be charged with a certain amount of transaction fee. Fair or not? Okay lah, fair lah. All right, that's why. A transaction will cost a gas fee. Okay. Okay, never mind. So later on, when we come to those relevant part, I emphasize one more time. Right. And then has code. Okay. Contract of course will contain code. Okay. External own account won't contain any code. Right. Okay, so the account address basically is represented by the last 20 bytes of the public key. Okay, so I think it's a bit shorter than Bitcoin address because only taking 20 bytes. Okay. Okay, the rest are not so important here. Okay, account portability. Of course, you cannot use this address in this testnet to send money to the real mainnet and so on. Okay, your money can only be sent to the same network. Okay, this is common sense. Okay, so let's focus on this slide. Okay, it's important for you to understand this. Okay, just now I asked a question about these signatures. Most of you are still not having a correct understanding. All right, so signing is needed for a transaction. Okay, I hope by now all of you understand. Signing is needed. Okay. Of course, when you are using your Remix, it won't require you to sign. Remix will prompt for you when you deploy your contract, when you call a function and so on. Would it prompt for you to key in a password, to sign your transaction? Have you ever noticed? You use Remix, right? Before, right? So, is there any occasion your MetaMask or whatever will prompt you and so on? Or if you are connecting to this the simulator from your browser, okay? So it will prompt you for signing. Please key in your password before you can send the money out. No, okay? It's configured in that way, so you do need to do this kind of thing, okay? You skip the signing. Basically, you need to sign every time you send out a transaction, right? So this is what happened, okay? So you prompt you, like your MetaMask and so on, you prompt you for passphrase, okay? This is your password, okay? For the password, actually, it will generate something called decryption key, okay? Because this is a key that is corresponding to the key that used to encrypt your private key, okay? So let's say you're connected to MetaMask, okay? MetaMask is your wallet, okay? Take care about your accounts, okay? When you want to use a certain account, inside of MetaMask you can have a lot of accounts, right? Correct or not? A list of accounts. You can select one account to use, right? Okay, select the one with money, then you use it, right? Okay? If you are trying to send a transaction using their account, you are the sender, okay? Using their account, you got money there, no problem. Okay? So let's say the transaction very simple, just transfer maybe 1 Ether to someone. It's a very simple transaction, okay? No problem for your apps to prepare those transaction contents, no problem, okay? But when you really use it, okay, you really send out a transaction, okay, you still need to sign the transaction, okay? You sign. This one you can run away. When you sign the transaction, okay, this is required by the protocol. You cannot run away, okay? Okay, so you need the private key because you want to do signing, right? You need a private key. But the private key, where to get the private key to sign? Where's the private key store? Have you ever thought about this question? Okay, the private key actually is stored in your MetaMask. You have MetaMask with you, right? Okay, so MetaMask, we have the private key, okay? So the private key is a very sensitive piece of information that you should always keep to yourself. You cannot disclose, right? Okay, must keep it to yourself. Okay, public key is okay, right? Okay, private key not. So you must protect it properly. So usually it will be protected. That's why your MetaMask always asks for password, right? Correct or not? Okay, the password that you're keying is to actually use to generate this decryption key. Okay, your private key is not decrypted using your password that you input. Actually, it go through a process. Okay, it actually use a key derivation function to generate this decryption key, and this is the key that go to decrypt your encrypted private key okay, by MetaMask. Okay, after the decryption, congratulations, you have the key already. You want to do the signing, you can go and sign already. Okay, MetaMask will sign for you. Okay, MetaMask will sign for you. Okay, this one you get the signature. Okay, you manage to sign and then you send out. Okay. I'm not so sure whether you have used or in your practical you have tried out recovery seed recovery phrases or not. So in any of your practical that require you to actually memorize the 12 phrases, no? Not yet or no? Yes, got practical. Yes, okay. 12 phrases, right? So Michelle asked you to do what? Record down. I don't know. Must record safely the 12 phrases. Oh, you are very blur. Or some of you not yet until that lesson. Any of you have seen the 12 phrases? I think when you first create your account, right? You need to create a wallet. That means you can have your account, right? Okay. Your prompt you are given if you create a new one, okay, you don't have any wallet before, it's a clean wallet, okay, then it will create wallet for you, right? Okay, so it will give you 12 phrases, okay, that one is called seed recovery phrases, SRP, okay. So have you ever wondered why you need that 12, or even more? Some you may choose to have 18, 24, and so on. So usually by default you ask for 12, right? Okay. So what's the purpose of that 12 phrases? You need to write it down and keep it somewhere safely. Make sure you won't lose it. You know what's the reason? The reason is because without that 12 phrases, next time, let's say you are using MetaMask, right? Maybe here you got your MetaMask in your browser. Okay, then after that maybe your computer broken, not accessible already. Okay, so how you going to access to your wallet? Your wallet will have multiple accounts, for example. Okay, account can be created by wallet, right? Wallet will do it for you, right? You want to have one account, it will create for you. You want to have another account, it can for you, right? You want to have the third account, it can create for you. The fifth account, the 20th account, and so on, no problem. Your wallet can create for you, okay? Let's say now you have 20 account in your wallet. 20, wow. You know, one account is very difficult to memorize, super long, right? Okay, if you have 20 accounts, how going to memorize? You know, right? Okay, let's say now, unfortunate, your laptop broken. You buy a new, cannot repair, okay. Now you buy a new laptop, okay? You got a lot of fun already inside your multiple account, right? In your wallet, okay. So you want to use MetaMask again, right? So what you do? You will re-download the extension, right? Okay, my question to you. Can you get back your account in your previous wallet? Got 20 account, wow. Got a lot of money also. Okay, so can you get back your account with those money? Those, the number of Ether still remain there. Okay, at that time, when you download a new extension for MetaMask, what you need to do is you're not going to create a new wallet again, right? Because you already got wallet. Your wallet previously, right? Just hilang because of broken laptop, right? Now you want to get it back, of course you install new extension, and then they ask you to create a new wallet or import your wallet, right? Okay, or recover from a previous wallet. Okay, so when you import your previous wallet, it will prompt you for what? Prompt you for the 12 recovery phrases. So it's very important, right? So if you have that 12 phrases, okay, recorded somewhere, just input one by one, okay. If you can input correctly, then you will be able to retrieve all your previous account. Okay, it's very wonderful. Okay, okay. So it works in this way, Okay. The purpose of having these 12 phrases is to let you to generate a master private key. Master private key, okay? And then for the master private key, there's a way for you to generate the first sub private key that you can give you the first account address. Okay? And also for the master private key, which is derived from your 12 phrases. This master private key depends on your 12 phrases. Okay? Your 12 phrases will always give you the same master private key. And then you run the algorithm to generate sub private key one by one. And the sub private key generated always the same. And you can generate as many sub private key that you want. Okay? Okay. Let's imagine, I key in correctly. I still remember. I still have the record of my 12 phrases. So I managed to get the master private key. Okay. So for the master private key, when I want to create a one account, because now you have new MetaMask with you, you have no account, so you create one account, right? Okay. So how it will be created? Very easy. Take your master private key and request to create one sub private key. Then that sub private key is just a random private key lah. And then you follow our address generation process, right? Then you get your account lor. This is your first account lor. Okay, then you use okay. How you get back your money? Hey, I lost my MetaMask already. All the money is still there or not? When I re-download the extension, I use the 12 phrases, get the master private key, and I create the first account for me. Hey, the account exactly like the one that I'm having previously. This account one is really at the address exactly same with my old one. Even though I lost them already, I don't remember and I didn't record. Doesn't matter. As long as I remember the 12 phrases. I use the algorithm, I create the first account exactly the same. And don't worry about money, okay? Because money is always recorded, money belonging to my account is always recorded in, let's say, Bitcoin, in Bitcoin, okay? You just need to total out, all the unspent transaction output, right? Total, you calculate from the past until now, how much Bitcoin you have. And then that information will be displayed on your wallet because your wallet will do the job. Because they contact the network and then pick up the balance for your account, right? Hey, then at the end you get, this account that I have, okay? And then the amount is, let's say 10 Bitcoin or Ether okay? You appear there. So you manage to recover back your money, okay? Because you have the knowledge about that address, right? From the record, I can see this is money related to this account, or this is also yours, this is also the same account. So I total up, then give you money. Congratulations, even though your laptop broken, your MetaMask day gone, you still have a way to recover back your account with the correct amount of money. And then you ask question, no last time I got 20 accounts, right or not? I only recover back one or how? Okay, then just ask to add your MetaMask to add another account. MetaMask add another account for me. Okay? Because from your 12 phrases that you remember, you create the master private key, right? For the master private key, you want to create a second account, I'll just ask the algorithm to do. You come up with the same sub private key, and then this one will lead you to your next account. Follow the address generation process are based on private key, right? Got private key, sure you can get account. And this account that you get for your second account exactly like your previous one that you generated with your MetaMask, okay? And the money also you can retrieve. Wallet, you do harder you do the job for you. Go ahead and check the network, okay? Find out and then show you how much you have for that account. No problem. They will say, I still got another 18 account, and then do the same, just add. You need to add one by one, no choice. You will not remember your newly download MetaMask, don't have knowledge how many account you have previously, right? You must remember how many you have. Okay, just click. Okay, then all the 20 account will be generated, and the money for all the 20 account also will appear. Okay, meaning to say you managed to recover back your wallet, just like exactly a situation in your previous MetaMask. Okay, if you don't remember, is it 20 accounts that I have in my wallet or 21? Mungkin okay, maybe there is a possibility I got 21 accounts. I cannot remember how. You just go and add in another one You ask wallet, MetaMask, help me to generate another account. So based on the master key, come up with the 21st private key, and then come up with your 21 account. Then wallet will check the network and see, zero. Zero. Okay, maybe I don't have any amount of this Bitcoin or Ether inside the network, right? It's fine. You want to create another one also can. Okay. So what to say is, basically the account is associated with the private key. Okay. So private key is very important, but we cannot remember private key for sure. Okay. But no problem, because all this the private key for all the account, the account number 1 until the account 20, right, is auto-generated. The private key is auto-generated by the algorithm. As long as you provide the correct master private key, is very important. Master private key. And this master private key, how you generate, is a fixed way. Okay, it depends on your correct input on the 12 phrases. 12 phrases. No 12 phrases. If you cannot remember, you cannot get a master private key. Then die, nothing we can do, right? So it's very important. That's why we emphasize. After MetaMask create the wallet for you, actually you have the ability to create as many accounts as you like. Okay, and in a very deterministic way. It's confirmed the same one every time you want to generate. Okay, so what you need to do, very simple. Keep properly your 12 phrases. Don't lose it. That's why you need to write in a paper, record, make many copies. That's very important. If you want to have control again over all the accounts that you generated previously. Okay? If no knowledge on the 12 phrases anymore, say sorry, okay? You cannot generate your account already. Okay? Okay, clear? So you can think of this as one of the sub private key that actually related to your account that allows you to sign this transaction. Okay. So anyone have any questions so far about transaction signing? Remember, transaction need to be signed. Okay, before it can be broadcasted to the network. Okay, let me see the timer. Okay. Let me give you this pin code first. Give me a moment, I forgot to screenshot the code. I need to log into the system.
这每次讲跟人家去看是怎样？
在电池里面
看不见。
吃饭。
你是痴汉吗？
是
伪汉。
你是家里吃饭吗？那不别人要不要吃？